Hi, in this session we are going to discuss about voltage divider rule, the definition for power and energy, and also we will consider one example on power calculation. Okay, so let us start with voltage divider rule. In previous session we discussed about current divider rule. Let me just recall that. Voltage divider and current divider rules are used for analysis of the electrical circuits. So the current divider rule can be applicable for the parallel circuit, or any parallel combination of resistors can be considered for the example of current divider rule. And current flowing through any resistor by applying the current divider rule can be calculated as the main current multiplied with resistance of other branch divided by sum of the resistances. Now the voltage divider rule will be applicable for the series circuit, or the series combination of resistor can be considered as an voltage divider circuit. So here we have taken an example for the voltage divider circuit, where the two resistances R1 and R2 are connected in series over here, R1 and R2. Now let us take V as the voltage source or the main source connected for the series combination, and current flowing through the circuit as I. So we will represent the voltage drop across R1 as V1 and across R2 as V2. Now we will see how we can find V1 and V2 by applying voltage divider rule. For that, let us first express the main current I as the voltage divided by the total resistance of the circuit. Since R1 and R2 are connected in series, we will take the total resistance as R1 plus R2. Therefore, I is equal to V divided by R1 plus R2. Now, we can express V1 and V2 by applying Ohm's law as V1 is equal to I into R1, that is V1 is equal to I into R1, that is current flowing through the resistor and multiplied with that particular resistance. V1 is equal to I into R1. Similarly, V2 can be expressed as I into R2. Here the current remains same through the resistor R1 and through the resistor R2. It won't be changing, but the voltages will be different. Okay. Now we can express the voltage across resistor R1 as, by substituting the value of I in V1. V1 can be written as V into R1 divided by R1 plus R2. Similarly, we can find the voltage across the resistor R2 as V2, which is I into R2. By substituting I, V2 can be expressed as V2 is equal to I into R2, which is equals to VR2 by R1 plus R2. Now, just let us have a look into the expression for V1 and V2. Here, V1 is nothing but V into R1 by R1 plus R2, and V2 is nothing but V into R2 by R1 plus R2. We can conclude the voltage divider rule, or we can express the voltage divider rule as voltage across any resistance can be calculated as main voltage into the same resistance, that is where we are calculating the voltage drop, divided by sum of the resistances. I repeat, voltage across any resistance or each resistance can be calculated as main voltage into same resistance by sum of the resistances. Okay, now that is V1 here, V1 is equal to V into the same resistance, that is R1 by R1 plus R2. I repeat, V1 is equal to V into same resistance R1 by R1 plus R2. Similarly, V2 is equal to V into R2 by R1 plus R2. Okay, so let us distinguish the statement of voltage divider rule and current divider rule. Voltage divider rule, voltage across any resistance can be calculated as main voltage multiplied with the same resistance divided by sum of the resistances. Whereas in current divider rule, current flowing through any resistance can be calculated as main current multiplied with resistance of other branch divided by sum of the resistances. Okay. Now, let us see what is meant by power and what is meant by energy. Power, the rate at which the electric work done in an electric circuit is known as electrical power, and we can express power as VI, and the unit of power is joules per second, or it is watt. Energy can be defined as the total amount of work done in an electrical circuit. The rate at which work done, we call it as power, and the total amount of work done, we call it as energy. And the energy is nothing but VI into T, and the unit of energy is joules or watt second. Okay. Now let us take another simple example where we can apply KVL, KCL, and also we will continue for the calculation of power. Okay, let me just go through the problem statement. A coil of 12 ohm resistance is in parallel with a coil of 20 ohm resistance. This combination is connected in series with a third coil of 8 ohm resistance. The whole circuit is connected across a battery having EMF of 30 volts and internal resistance of 2 ohm. Calculate terminal voltage of the battery and power in 12 ohm coil. From this problem statement, we will have to draw the circuit diagram first. Okay, a 12 ohm and 20 ohm resistance has to be connected in parallel, and this parallel combination will be connected in series with 8 ohm resistance. Accordingly, here we have taken 12 ohm and 20 ohm resistances in parallel, and this combination must be connected in series with 8 ohm. The whole circuit is connected to the battery. This whole circuit is connected to the battery having the internal resistance. So always the internal resistance of the battery will be connected in series. So we have connected 2 ohm resistance in series with 30 volt battery. Okay. So here we need to first calculate the terminal voltage of the battery and then the power in 12 ohm coil. Okay. So terminal voltage of the battery can be calculated by knowing the voltage drop due to the internal resistance of the battery. So voltage, in order to find the voltage drop, we must know what is the current flowing through 2 ohm resistance. So first we have to calculate the total current flowing through the circuit. Okay, and later we can find this power in 12 ohm resistance by finding the voltage between the point A and B. Okay. First, in order to find the current I, we will have to find the total resistance of the circuit. Just have a look into the connectivity of the resistance over here. Here, let us solve 12 ohm and 20 ohm combinations in parallel, and we will take that resistance as RAB. So 12 ohm and 20 ohm resistances are connected in parallel. We will solve that first by using 12 into 20 by 12 plus 20. That is, if any two resistances are connected in parallel, the total equivalent resistance can be calculated as R1 R2 by R1 plus R2. We have applied the same rule over here. And here we have obtained the value as 7.5 ohms. Let us find the total resistance of the circuit. Now 12 ohm and 20 ohm we have replaced with RAB, and this combination is in series with 8 ohm and again in series with 2 ohm. So we have to take RAB plus 8 ohm plus 2 ohm to find the total equivalent resistance. So our total is RAB, which is 7.5 ohm, 8 plus 2, which gives us 17.5 ohm. Okay, so using this total resistance and also the value of voltage of the battery, we can find the current flowing through the battery or the current drawn from the battery. So I is equal to V by R. V is 30 from the given information divided by total resistance is 17.5. We get the value of I here as 1.7 amps. Now, so we know the current. Now we can easily find the voltage drop in 2 ohm, that is in 2 ohm resistance. So voltage drop across the 2 ohm resistance can be calculated as current into this 2 ohm. So the value of current is that is with this expression, internal resistance into current. So by substituting I, we can find the internal voltage drop due to 2 ohm resistance as 3.428 volts. Now the terminal voltage will be calculated by subtracting this voltage from the voltage of battery, which is 30. So here we get the terminal voltage of the battery as 26.57 volts. Finally, we can calculate the power in 12 ohm resistance as, we know that P is equal to V into I, and I can be expressed as V by R. Therefore, P will be V square by R. So we have used that expression over here. You can also use the alternate expression for calculating the power. That is, you can make use of current instead of voltage. Okay. So, but we must know what is the current flowing through 12 ohm resistance and through the 20 ohm resistance. So, I will be dividing in 12 ohm and 20 ohm. So, it is better to go with this approach rather than using the current values. So, I have chosen the second approach, that is P is equal to V square by R. So, here we know the resistance between the terminals A and B. The resistance between terminal A and B is already calculated. And let us simply find the voltage between point A and B. So which we can calculate it as V is equal to I into R. I is the total current and R is RAB. So which gives us the voltage value. So using that we have calculated here the voltage between point A and B as 12.85 volts. Now power is equal to 13.77 watt using this informations. Okay, so this is how we can apply the necessary fundamental rules, and we can calculate the unknown parameters and also the value of power in any resistances. Thank you.